Muhammad. Ya Allah yang mengatur alam semesta ini, tiada kata yang patut kami haturkan melainkan sanjungan tertinggi bagimu, karena hanya atas kuasa dan izin-Mu lah sampai hari ini kami bisa melanjutkan pengabdian kami kepadamu dengan mengabdi kepada alma mater, bangsa dan negara. Ya Allah yang maha pemberi rahmat, atas rahmat dan petunjuk serta nikmat dari-Mu lah kami pada pagi hari ini diberikan kesempatan untuk melaksanakan kegiatan ini. Untuk itu, ya Allah, jadikanlah kegiatan kami ini sebagai kegiatan yang Kau ridhoi, yang membawa berkah, rahmat, taufik, dan juga hidayah-Mu. Ya Allah, Tuhan yang maha memberikan petunjuk, kami ini hamba-hamba-Mu yang sangat lemah, dan kami akui kelemahan diri kami. Kami sadar dan mengakui kejahilan, kedhaifan, kekhilafan, serta ketidakberdayaan kami ini. Maka dari itu, ya Allah, bimbinglah kami, berikan kami petunjuk, serta jauhkanlah kami dari jalan yang sesat dan tidak Engkau ridhoi. Ya Allah, yang maha pengampun, Engkau maha mengetahui terhadap kelemahan dan juga kekurangan kami. Maka dari itu, ya Allah, kepadamu-lah kami menyembah, kepadamu-lah kami memohon ampunan dan pertolongan, serta hanya kepadamu-lah kami melakukan pengabdian. Ya Allah, kabulkanlah doa dan permohonan kami. Rabbana ighfir lana wa liwalidayna warhamhuma kama rabbayana shighara. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Walhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Excellencies, participants, ladies and gentlemen, our today's event is about sharing knowledge on hazards, risk, and resilience. And here we are, arrived at the main agenda. Let's start our session under the lead of Dr. Musli. But before that, please allow us to read the CV of our moderator quickly. Dr. Muzila's education history in the Department of Geophysics at Nanyang Technological University, Singapore from 2017 to 2019. And currently he's a lecturer at STMKG, and there are many publications that he has been published, as you can see on the screen. And he has also received the award scholarship holder of the German Academic Exchange Service, or the AAD, in 2006-2009. And he's also a member of Indonesian Association of Geophysics in 2006 until now. I think that's all short reading for the moderator CV. Without any further ado, for Dr. Musli, please welcome.
Thank you, MC, for the introduction and inviting me to be the moderator of this important lectures this morning. Welcome, Professor Bruce, to STMKG, and welcome to all participants. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. All right, so today we have the talk about hazard, risk, and resilience. And actually will also relate it with the social media. And based on the BNPB, or National Authority for Disaster Management, in last decade, 2013 to 2024, there were more than 10,000 fatalities due to natural disasters in Indonesia. So, and then we also still remember the 2004 earthquakes. There were more than 200,000 fatalities in Indonesia, and also some other, many other natural disasters. This means Indonesia still have a big problem in hazard and risk mitigation of the natural disaster. So today we will have the talk about this, about hazard, risk, and how to mitigate it, and also as we talk about this with the professor, so we will also have besides the hazard and risk, also the social media. So please pay attention to the talk, and you have the students have the time for the discussion with the professor. I believe after this talk we will have knowledge much more about hazard, risk, and resilience. So we will talk. We will start the talk soon. We have the time from now until more or less 10:30 before the discussion at the end of the talk, and then you also have the time for the questions, including for the online participants. So we have here the participants from STMKG, the students here. We also have participants from regional offices of BMKG, which is online. So later, for you participants online, you can ask the question through the chat box. All right, let me introduce the speaker, our invited speaker today, Professor Bruce Malamud is a professor, research scientist. He is actually we found this on the website. You were the but you mentioned that you were the professor at Department of Geography, Durham University, UK. But recently, currently, actually, you are the executive director and Wilson Chair of Hazard and Risk in the Institute of Hazard, Risk, and Resilience. Professor Malamud completed his PhD in geophysics from Cornell University in US. His research, this is important, his research focused on multi-hazard interrelationship along with single hazard research in landslide, earthquakes, floods, and wildfires. So he has a lot of publication with the citation more than 10,000. All right, so that was a short introduction of the Professor Malamud. We welcome to Professor to give the talk. Time is yours, so please. Thank you.
So thank you very much for inviting me. It's just a pleasure to see everybody here. Good morning, everyone. And Assalamu alaikum, and I hope everyone is well this morning. Just so I have an idea of who you are, could I have a show of hands of how many of you are second-year students? Second-year students, just put your hands up. Okay, fourth-year students? Okay. So it's, how about third-year students? Ah, okay, so it's the third-year students. Any first-year students here? No, okay, so second, third, and fourth-year students, that's fine. And how many of you are doing climatology? All right, meteorology? Good, geophysics? And instrumentation? All right, so we have a good selection here. Okay, if we could do the slides, that would be wonderful. And I'm just going to take one picture from this vantage point, and I will do the timer here. Okay, dog. All right, so I'm going to talk about hazard, risk, and resilience today. I'm going to look to the moderator here, thank you. In case I'm starting to speak too quickly, you can wave your hands and say, hey, you're speaking too quickly, all right? The slides that I will present today, I will make available to you afterwards because some of the text you might not be able to see. It might be a bit too small, all right? So what I'm going to do today is, first of all, for advancing slides, you advance the slides? Okay, so do I tell you each time? All right, got it. All right, so before I begin the seminar today, what I want to talk a little bit about is I've already had a very nice introduction, thank you. I'm going to talk a little bit about myself, who I am. Durham University, just so you have some idea where in the United Kingdom it is, because many of you have never heard of Durham University. The Geography Department at Durham University, because this would be one of the likely places you would study for a master's degree or for a PhD if you were to go on for further studies. And then the Institute of Hazard, Risk, and Resilience. So first of all, myself. I am, and this will be quite small, I'm just curious, is there a way to make it so this expands to the whole screen? Thank you. And maybe just the slide. Perfect. And can we do that for all the slides so that they'll be bigger? That's perfect. Thank you. So as was mentioned, I'm the director of an Institute of Hazard, Risk, and Resilience at Durham University. My training is in physical sciences. So that means when I was your age, I was actually getting a degree in physics. And I thought that I wanted to do a career in lasers and optics. But then I spent 2 years in Africa. I was a high school teacher there. I taught physics and chemistry. And I saw the world around me. And I saw extreme events, storms, dust storms, and drought. And so I decided to change into the earth sciences. Now I study a range of single hazards. So I look at earthquakes, floods, fire, wildfire, and how humans influence these. And then what are the interrelationships? And that's what I'm going to talk about today, are the interrelationships between different hazards. So if you take one thing from today's talk, is you will be studying one very specific field. Don't forget that all the environment is interrelated. And just because you study earthquakes, you also need to know about floods or tornadoes. You need to think outside of your specialties. My research over the past 6 years, I've done research in Turkey, in Kenya, in India. I finished up a large project on landslides and early warning a couple years ago. Philippines, I'm going there tomorrow, and I've just come from Thailand. So I've worked in a variety of countries. If you're interested in knowing more about me, there was an interview not about my science, but about the life sort of that is behind the science. So Durham University is in the United Kingdom, and how do I point? Is there a pointer? No, okay, that's fine. So the purple here is Durham University, and we're located about 3 hours by a train ride north of London. So we're in the northeast. It's a beautiful city, it's a smaller city. Next. So Durham University is old, like many universities in the UK, 1830s. It's the third oldest university in England. It's very much an old town, and you can see the castles and the buildings there. 30% of our students are international that we get there. Next. We have 4 faculties, 27 departments, and I'm just going to focus in and give you a couple slides on geography. So the geography department is one of the largest in the United Kingdom. We have almost 900 students there. So it's about the size of your campus here. I understand you have about 1,000 students here. 150 now you're doing in each cohort. There's about 70 academics and 25 administrators. Next. So it's ranked first nationally, and is consistently ranked as one of the top geography departments globally. Next. We have a rich and vibrant research culture there, and we go from the physical sciences to the human sciences. We have lots of laboratories and all the equipment that you would expect of a world-leading department. There are 3 master's programs there, and if later, after you finish your undergraduate degree, you become interested, you can start reading about these programs. We have quite a few programs that are directly related to climatology, meteorology, geophysics, and also instrumentation. And we have a really rich master's students, but also a lot of PhD students. So the Institute of Hazard, Risk, and Resilience, which I just started directing about a year ago, is about 20 years old, and we're a research institute. So what that means is we cut across the departments. So I don't just work in geography. I also work with the business school, with earth sciences, with physics, with the data scientists, and we think about hazard, risk, and resilience as to how it goes across all of the disciplines. So we go from the physical sciences to the social sciences, and we think about interdisciplinarity. Next. So we think about forecasting hazards. What are cutting-edge tools? These are things that you're learning about. We think about risk, and when we talk about risk, we're not talking about just hazard. We're also talking about the roads around us, the buildings around us, the exposure, the population, and we're talking about the vulnerability of people. What's the age of people? What's their ethnicity? What's their disability? So all of these play into risk to hazards, and we think about the resilience. How do communities bounce back from different disasters? What is their ability to withstand different shocks to the system? So within the Institute, we focus on 4 main areas. So in the far left, we look at single and multi-risk for strategic future planning. And this involves modeling, it involves computers, but it involves also social scientists thinking about interviews. What do the people think? The second to the left is tools and methodologies. So one of those that I'm very keen on is virtual reality. I'm just curious, how many of you have done virtual reality? Anyone? Where you put a headset on and you see things in 360 degrees? So this is going to be something that's going to be very important in the future. It will become more affordable, and you will need to be the leaders in thinking about how this applies to hazard and risk while you are working with the BMKG. I met with the deputy head of geophysics yesterday and talked to her about virtual reality and how important this is going to be in the future. The second to the right, climate adaptation. How do we adapt to a changing climate? How do we recover from disasters in the short term, the medium term, and the long term? What's the resilience of food supplies? So if you have a volcanic eruption, how is that going to affect food and the supply chains? These are modeling that you will need to be thinking about as you go forward. And then the far right is the empowerment of local communities. So you may come up with a good model or a good instrumentation, but how will the local people use it? How will they understand it? Next. So I'm going to focus here for the next 49 minutes, because I have my nice little clock here telling me what time it is. I'm going to focus on I'm going to focus on multi-hazards. And I want you to start thinking now about not just I'm studying earthquakes, or I'm studying landslides, or I'm studying climate, but rather how they interlink with one another. So now we come back to multi-hazard interrelationships and dynamic risk scenarios in a turbulent world. And we want to think about what it is that we are doing to interrelate these. I just want to do a sense check here. How is the speed of my speaking? So how many would say it's okay, you're understanding everything? Okay, so that's about 30% of the people raise their hands. That gives me a good idea of who is understanding and who is not. Okay, next slide, please. Good. So this will be ordered in 5 parts. Afterwards, we'll have question and answer. You can ask questions on anything. It could be about my time in Africa. It could be what it's like to live in Durham University. It could be technical questions. So the question and answer will be open to anything to do with hazard, risk, and resilience. I do many more things than just this. So I also look at social media, X, how we use it for things, newspapers, other things. So let's start off with single hazards. So you're all aware of things like landslides and volcanic eruptions and hail and flooding. And these are just some examples of single hazard types. And there's many examples of single hazard types. Each one sometimes comes with impact. So the landslide in China had over 83 fatalities. The volcanic eruption in Indonesia in 2017, there was a lot of panic. It affected tourism. There were injuries. It had impact on local business. The flooding in Gujarat in India, there were over 200 fatalities. And this was mentioned in the introduction. Last year, there were over 10,000 fatalities. So that was a lot. Next. And so in Indonesia, we see this come up in the news constantly. And I just did very quickly this morning, I was looking at the news for the last year, and we see come up in the news floods, and in Badung, the hail and strong winds, and we see more floods and volcanic eruption, the extreme weather. So constantly, this is why it's very important what you are going to be doing in the future. You will be thinking about these hazards and how you can help the population in terms of its resilience. So that might be modeling, it might be instrumentation, It might be doing interviews with people for social sciences. So I've been meeting many people from BMKG. Yesterday, I was able to spend 6 hours a day with them in workshops and lectures. And I've been familiar with the BMKG for many years now. So what we're going to do here is we're going to identify and we're going to broadly classify natural hazards. And we're going to classify them into geophysical, and you're familiar with geophysical. And the geophysical will be earthquakes and tsunamis and volcanic eruptions and landslides and snow avalanches. The hydrological will be floods and droughts. The shallow earth processes will be regional subsidence, ground collapse, soil subsidence and ground heave. The atmospheric, you're familiar with, will be storms and tornadoes and hailstorms. Lightning is often forgotten about, extreme temperature, heat and cold. Then we get into the biophysical, the wildfires, and finally space. We can't forget about space hazards. So these would be the asteroids that come in, the impact hazards, but also the sun. The sun has flares from it, and we get geomagnetic, we get activity from this, and this can affect communications. So we're broadly going to break all the hazards into these 21 types, and we're going to come back to this classification later. Now this is just the slides are a bit small, but on the x-axis here is the scale of different natural hazards, and it's on a logarithmic scale. So this means we're going up by orders of 10. And we're going from kilometers squared to tens of thousands of kilometers square. On the y-axis here is the temporal scale, and it goes from seconds to hours to millennia. And it's just to remind ourselves that when we talk about floods, we're not just talking about a very, very big flood, but floods can range from small to very big, from kilometers squared to thousands of kilometers squared. And the time over which floods can occur can be from hours to months. And we can do this for every hazard. And the idea is in the news, we often just see reported the very biggest events. But in fact, there's a continuum of events where they range from small to big. It is your job not just to focus on the biggest events, but also to think that there's medium events and small events that also might be creating impact. So those are all about single hazards, and now we want to think about multi-hazards. So multi-hazards have two major approaches. The first approach in A on the screen is a multi-layered single hazard approach. And this is where we take the risk from floods, we take the risk from volcanic eruptions, we take the risk from tsunamis, we put them all into the same GIS, and we say we accumulate the risk. That is what many, many countries are doing now, and 10 years ago, much of the West was doing. The B, the holistic approach, is to think about the interrelationship between the hazards, that they're interconnected, they're interacting. We cannot just operate within silos for our disciplines. So that means the climatology people need to be talking with the geophysical people. The geophysical people need to be talking with the meteorology people. You all need to be talking with one another and understanding what the others are doing in their discipline. So if we look at the single multi-layered approach, this is an example. The earthquake risk, the landslide risk, the flood risk, and then we just add them up. And this is an example now from the Philippines, where I'm going tomorrow. Next slide. Thank you. So this is the Philippines, and I'll be there tomorrow, and I've been working with a PhD student there for a couple of years. So I have PhD students in India, in Philippines, in Africa. And there they have similar. There's a flood hazard, there's a landslide hazard, there's a storm surge hazard. And people can click these on and off, and they have a very good database. I'm just curious, how many of you are familiar with the National Operational Assessment of Hazards from NOAA? Anyone? Okay, you might want to look at what other countries are doing also, because this is a fascinating database that they've put a lot of funds into. So the holistic approach is thinking about the interconnectedness. And only about 10 years ago did we really start thinking about this. And I was lucky enough to be amongst the leading group of authors to really start thinking and writing papers and doing research on multi-hazard interrelationships. So there are many examples of research projects that are being done, and you'll hear the word multi-hazard often. And you have to ask yourself, when I hear the word multi-hazard, so that means multiple different hazards, do they mean single hazards and overlaying them in a multi-layered approach, or are they looking at the interconnectedness? So multi-hazard means the selection of multiple major hazards that the country faces and the specific context. And this is the important part. This is from the United Nations. This plays into the Sustainable Development Goals. That the hazard events may occur simultaneously, cascadingly, or cumulatively over time. And they take into account the potential interrelated effects. So we go from thinking of single hazards to the interrelationships between them. So I'm going to give some examples now. A volcanic eruption in Japan, it triggered a landslide, and the landslide triggered a tsunami. They're interrelated. We expect that volcanic eruptions can often trigger landslides. And in the right here, I like using things that are from the past to help inform us for the future. And so this is just an example about how you can use archival material from hundreds of years ago to better understand the past. And Indonesia has a very rich culture of records of disasters from many hundreds of years ago that can be tapped into. Another example would be in the Philippines. So at the same time that we had a volcanic eruption which triggered earthquakes and global cooling in 1991, we also had a typhoon. They were completely independent, and the typhoon triggered a lahar and triggered floods, so you get a cascade of hazards occurring. You can keep looking at other examples. This was a rainstorm, triggered a landslide, triggered a flood. And it was these examples from China that in the late 2010, 2009 that got me thinking about multi-hazard interrelationships. Because what would happen is in China, there were a couple of events where there was an earthquake. The earthquake caused many fatalities, but then after the earthquake caused many landslides. And then the landslides built up in the mountains, and then there was extreme rain. The rain came and broke through, and there was flooding. And so when the earthquake occurred, the hazard managers, that's going to be you, were not thinking that it might result in a flood. And there were many, many thousands of fatalities from the flood. So there was just a lack of understanding that there's an earthquake. We also need to think about the cascades of hazards that might occur and how it might affect the population. And that's when I really started to think there's a lack of understanding of multi-hazards and how they might affect the local population. And we can keep looking at examples. So Krakatoa in Indonesia. Next. We have earthquakes triggering loss. We have Merapi, heavy rain. And we can keep coming up with many more examples where we can think of different hazards and how they cascade to result in other hazards. So many examples here. And I have had many master students and PhD students work just on creating case history studies for their region. And this makes, by the way, for a very good undergraduate dissertation, master's dissertation, and PhD project to really think about the history of multi-hazard cascades in a region. So why are these approaches useful? Treating hazards as being independent can distort management priorities. It'll underestimate the risk. The vulnerability can increase between successive hazards. It increases the vulnerability and exposure to other hazards. If I have an earthquake, then it's going to potentially increase the vulnerability to floods in months to years afterwards. So we need to start thinking not just about the earthquake, but the flooding that might result afterwards. So understanding the multi-hazard dynamics can help us improve risk reduction planning and response. So we need to start thinking about what's the interrelationship between different hazards. There's also a lot of increased attention, not just in the physical sciences, but also in the social sciences on multi-hazards. So I gave a talk a few weeks ago to the business school at Durham University, which is, by the way, one of the top in the UK and very renowned globally. And there were a bunch of business people. And one of the things I started to think about was, well, what are the effective disasters which the business people might be interested in? And so I started looking at papers, and they're interested in the infrastructure costs, the supply chains, the organizational resilience, and then things like health systems. And so actually many people, many students from the business school came up to me afterwards and said, we really want to start thinking about this. So what you're doing has impact also in society, and there are linkages into it. So there's increased attention on multi-hazard cascades in many different spheres of the community, and we're very worried about these, particularly with climate change, with the population moving from rural to urban areas. We have more bigger footprints of disasters that will occur, and these interacting hazards, these complex disasters are going to become more and more common in your lifetime. So we'll need to be thinking about that. So in the rest of this talk, I'm going to talk about natural hazard interrelationships, anthropogenic processes, these are how humans influence, dynamic multi-hazard risk scenarios. And each one of these are from my perspective. And I'm just one scientist of many. There are many scientists, by the way, at Durham University doing different fields. Some are instrumentation, some do global climate modeling. So I just happen to be one that looks across disciplines. So let's do natural hazard interrelationships. So I'm going to show some graphics here. And all of this, by the way, is an example of what a first-year PhD student can do. So this was work that I did with a first-year PhD student who came to work with me, and we then published it. And this has become very highly cited since then, 10 years ago. And I've written a number of papers with him. I've also, by the way, published with master students. And so being a master student doesn't mean you'll never get a publication. You just have to work with the right person. Next. So we're going to start with a 21 cell by 21 cell matrix. And I know you were thinking, oh no, we thought we were going to get a fun lecture here. But there are going to be a couple of graphs here where I will show you things. And on the y-axis, we're going to have the primary hazard, and on the x-axis, the secondary hazard. And we want to think about pairs of hazards that might occur. Next. So these are all the hazards that I showed you before, the geophysical hazards. Next. Hydrological hazards, the shallow earth processes, the atmospheric hazards, and the biophysical and space hazards. And so we're going to repeat these hazards as primary and secondary, and we're going to ask ourselves the question, does an interrelationship exist between one hazard and the other? So I'm just going to get a quick show of hands here. I'm going to give you two hazards, and I want to know if you think there's an interrelationship between them. So, earthquakes, landslides. How many of you think there's an interrelationship? Okay, and it's interesting, it's everyone on the left side of the room, but not on the right. So, earthquakes and landslides. Can earthquakes trigger landslides? How many of you would say yes? That's better. That's everybody in the room. Can earthquakes trigger floods? Okay, people are not as sure there. That's interesting. And the answer is, by the way, yes, they very much can. Can earthquakes trigger a tsunami? Okay, everybody is very definite on that. And we're going to do this for every possible hazard interrelationship pair. So the next one, and we're going to do this for every possible pair here. So we have 21 cells. By 21 cells, that means we have how many possibilities? Okay, so 21 times 21 would be 441. And you get, so you can just do that in your head very quickly. So there are 441 possible pairs here. And what my PhD student did is he looked at every single possible pair. And how did he do that? He used the literature. He used expert knowledge. So earthquakes triggering a tsunami, that's easy. We know that exists. Earthquake triggering floods, we find the literature for that. And we're going to look at every possible pair. Now we're going to do a couple of other things here. The first is we're going to differentiate between triggering and amplification relationships. So an earthquake can trigger a landslide. The energy from the earthquake shakes the ground and a landslide results. But we also have increased probability relationships. So I'm going to give you an example. And this is a forest fire. Will change the background environment. And so what happens in a forest fire is it removes vegetation, it hardens the earth. And so in the weeks to months afterwards, if there is a rainstorm, what will happen is it will break through that top layer of the ground, and you might have a catastrophic landslide result. And so what we're going to say is that's an increased probability relationship. It's not the energy directly that's causing the landslide from the wildfire, but rather it's changing the background environment. And so we'll shade the top of the left cell for triggering, the bottom of the right cell for increased probability, and the entire cell for entire grid. And by the way, I should mention, this is a talk I give my second year undergraduate natural hazard students. Generally, I get about 100 there. And it's a mixture of physical and human geography students. I also give them the paper to read. We have exercises, and we do this over 2 hours. So this is the sort of lecture that I would be giving, maybe the 5th or 6th lecture into the term, just to give you an idea of where this comes. Next. And we're also going to color code it. So a light gray is going to be the potential for a small number of hazard events. So an example would be an earthquake will trigger 1 tsunami. Dark gray will be if it can trigger many, many of the events. So an earthquake can trigger thousands, hundreds of thousands of landslides. Next. And then after months and months of work, my PhD student and I came up with the following graph. And I'm going to show you some examples here. But basically, out of the 441 possible, there's over, so there's 90 possible interactions that we were able to identify. And I've had many master's students do similar work for a particular country or a particular region. So let me show you some examples of this. A landslide can trigger a tsunami. So we fill in the little square in the upper left-hand corner. A volcanic eruption can trigger and increase the probability of a landslide. So we fill in that square. VO intersects with LA. Next. And so a volcanic eruption, we learned from this chart, can trigger earthquakes and tsunamis and landslides and snow avalanches and floods, lightning, extreme temperature, and wildfire. Landslides can be triggered by tsunamis and earthquakes, and those you're familiar with. You had a very big event which was a tsunami caused by a landslide not so long ago. And actually, after that occurred, I lectured about that to my undergraduates in the couple days that followed that. But landslides can be triggered by volcanic eruptions, but some that you might not think about is from a hailstorm. If you have a lot of hail, it can cause a lot of mass and water, which can trigger landslides. And so we start thinking more broadly about what can trigger landslides. And these, in turn, can trigger many other hazards that can occur. And so now we can start seeing multi-hazard cascades result. So a volcanic eruption can trigger a landslide, which can trigger a flood, which can trigger a ground collapse. And so you can see the arrows now. You can start circling the cascade of hazards that might result. Or another example would be a storm can trigger a flood, which can trigger a landslide, which can trigger a flood. There are many examples that you can have. So that's a very brief overview to hazard interrelationships. And main thing I want you to take away from that is that hazards can be interrelated one with another. Now we're going to move into anthropogenic processes. And we want to think about humans, how humans can influence anthropogenic processes. And this is a paper. All of these papers you can download for free. They're all open access. They're all accessible. So the language, hopefully, you will be able to understand. Undergraduates should be able to understand these without a problem. Next. So what is an anthropogenic process? So far we've talked about natural hazards, earthquakes and floods and tsunamis. Now we want to think about human activities. And these are non-malicious, but may have a negative impact on society. And they trigger or catalyze other hazardous processes. Next. So thus far, we've thought about primary hazards and how they might affect secondary natural hazards. So we focused on different natural hazards, but we also have technological disasters, buildings collapsing, and we have anthropogenic processes. And so they're all interconnected. And I'm not going to talk about technological disasters here. So examples would be a dam collapse, but these are very important also. And instead, we're just going to focus on anthropogenic processes. And I'm going to give you some examples. I'm just going to give you a few slides on this, and then we will go to dynamic risk scenarios, and from there we'll go to questions and answers. So let's classify anthropogenic processes into 3 groups. And here we're thinking about things like extracting water from the ground. And so what happens if you pump water or extract water from the ground? What might result if you take water out of the ground? Any ideas? So just shout out, what happens with oil being pumped in and oil being pulled out of the ground? What natural hazard might result? So someone said landslides. Anything else? Okay, I've heard earthquakes from someone in the back. Earthquakes can result, and we're quite worried about the pumping of fluids into the ground and pulling them out, that might result in earthquakes. There's a real concern amongst the community. Vegetation removal. So what might vegetation removal accelerate in terms of natural hazards? Drought, very good. And I've heard fire from another person. So fire can be accelerated when you have vegetation removal. So each one of these we'll be thinking about. And what we're going to do is we're going to look at the anthropogenic processes, so the groundwater abstraction and the vegetation removal and the urbanization, the infrastructure quarrying, the chemical explosions, the fires, the urban fires, and how they might influence natural hazards. So again, this was a project, and we looked at every linkage possible between anthropogenic processes and natural hazards. And we said, earthquakes, vegetation removal, how do those influence different natural hazards? And we looked at systematically to find evidence for these. So an example is here. Groundwater abstraction can trigger an earthquake. So we fill in the square and say, okay, tick. And by the way, for all of these papers, if you go to each one of these squares, there is evidence. There's a paper that gives evidence for this. So there's a big spreadsheet of data and information associated with these graphics that you're seeing. Next. So another example would be oil or gas extraction. So if you extract oil from a large region, you can actually cause regional subsidence where the ground starts to go down a bit. And so what we found were 57 anthropogenic process natural hazard links through a systematic review of the literature. And so then that we can start bringing into our thinking of what we did in the last section for natural hazards. And now we can say, okay, vegetation removal can result in landslides, but a landslide can result in a flood, and a flood can result in ground collapse. And so you start thinking systematically how the anthropogenic processes might influence different natural hazards. So we'll come to this in the next section. So let's go to the next section now. And this is dynamic risk scenarios. So now all of this is very theoretical right now. Now we want to bring it back to people such as yourselves and policymakers. And so now what we're going to do is we are going to do this in individual cities, and we're going to think about what might be locally specific. And this is work I've been doing over the past few years. So a couple weeks ago, we published the paper on the left, and I'm just curious, I'm going to get a show of hands here. How often are you asked to read publications from the peer-reviewed literature as a part of your courses? So are you ever asked to read somebody's paper? I'm going to look. They do, okay. That's why I'm looking at you, because I'm wondering if they're understanding the question. Okay. How many do they get? Do they get like 1 or 2 a week or term?
Actually, not very often.
Not very often, okay. Maybe we can talk about that afterwards. So in my class, I would be assigning 1 or 2 papers like this a week to my students. And they would be expected to read it in addition to the textbook. And these are things you can download from online. This is research that you want to be doing in the future. It's in English, some of it's very accessible. So on the left is a publication. The first author just had graduated from his PhD. He's now a postdoc. The second author is my PhD student. She's working in Kathmandu. And this was published a couple weeks ago, and the one on the right. And here we're going to look at Nairobi, Istanbul, and Kathmandu, each one separately. I am very interested in doing this, by the way, in Jakarta, what I'm going to show you, because I'd be very interested in the results of what we find. So let's go on. So what we do is we first identify all single natural hazard types that might influence Istanbul, Nairobi, or Kathmandu. These were separate projects, but I'm going to put them all together on one slide. And I'm just curious, do they do an undergraduate project or dissertation?
Yes.
Okay, good. This has been the subject of a number of undergraduate dissertations, by the way. I've had maybe 150 undergraduate dissertations that I've overseen because I've taught for 30 years. I have to think about that, though. And I've had maybe 50 or 60 master's dissertations that I've overseen. And so what we did is we went to peer-reviewed literature, gray literature, that would be like government reports, newspapers, social media, databases, expert input. And we found examples in YouTube and other things just to identify the single hazards that might result. So on the right, I'm showing you some of those examples. So for instance, Nairobi extreme heat, this would be from the TV broadcast. And we put together all of these sources of information. So we had over 190 sources that we used. And then we systematically categorized this in Excel. So I still believe in using Excel for some things. And we categorized them systematically with headers as to the hazard type, the information, the content, the hazard interrelationship, the anthropogenic influence, the video evidence. So we found YouTube videos for everything that we could, source reflections, and other reflections. And then what we asked ourselves from this is which single hazard types are representative in every city. And you'll find here that for these cities, there's a broad array of single hazards that might influence the city. And I'll come back to this, but this was very impactful to the stakeholders. And we met with people such as yourselves in BMKG later on when you enter the BMKG, with academics, and they were very surprised at how many different natural hazards. So for instance, Nairobi, they're more focused on floods and urban fire. That's what they're worried about. When I brought in hail and lightning, these others, they said, you're right, we hadn't thought about those. Maybe we need to start thinking about them. And also, the people that are working on earthquakes, we're not talking with the people working on floods. And so it was getting the different siloed parts of the government working together. What we then did is we systematically noted 2 types of potential multi-hazard interrelationships. The triggering relationships that we talked about before, and the probability relationship. So on the right is an example, a storm triggers a landslide. And there are many examples in Indonesia. Earthquake triggering tsunami, volcanic eruption either increasing the probability or triggering a lahar. And we can go through and construct many examples in Indonesia. And so what we then did is we did a similar matrix as we did globally, but we did it very locally for each of these groups, and we identified the potential interrelationships. The other thing we did is we asked local people, what hazards do you think we need to include that are not included? And Istanbul came back to us and said, we are very concerned about fog. Please include that. And Saish. And Saish is basically the waves moving back and forth in a harbor. Nairobi came back to us and said, we really are concerned about urban fire. Could you please include it even though it's anthropogenic? So we included it. And so now we have a 24 cell by 24 cell matrix. It's similar to the one that I showed you before, but we've added a few other hazards here. So you can make this locally specific to what you feel will work best for your region. And this is what we found for Istanbul as one example. We did this also for Kathmandu, we did it for Nairobi, and we looked at what hazard interrelationship pairs might occur for that region. So an example would be a storm can trigger a landslide, which can trigger a flood, which can result in other cascading hazards. And so we put together these background work, the secondary work, and then we met with teams of people from each city. So we want to extend these hazard interrelationships to dynamic risk scenarios. And this is a word I'd like you to think about. What do we mean by dynamic risk? And I'm going to give you a couple slides on what we mean by risk in a moment. And we want to include anthropogenic processes and how urban areas might change in the future. So let's take an example. And these are going to be a whole bunch of slides rapidly moving, so I'll just keep nodding my head. So an earthquake can trigger a tsunami, and that can trigger a landslide. So another example could be, and that can increase the probability of flooding. So another example would be a heat wave that can trigger a drought, and that can trigger a wildfire, and that can then trigger local soil subsidence. So what we can do is we can go from the matrix and we can create potential scenarios. There's many, many that we can do here. And what we end up with are example scenarios that might occur in a given region. And so we put these together. And then what we want to start thinking about is hazard, exposure, vulnerability, and dynamic risk. So just as a reminder, the hazard is the potential magnitude of a given type of hazard, including the probability of a given size occurring in a defined period of time in a given region. So how big, over how much time, and what region it might occur in. The exposure might be the roads and the buildings, and the vulnerability would be the characteristics of the people. If they're older, it's more likely they'll be more affected by certain types of hazard. All of these combine together to be risk. And again, a show of hands, has this been introduced in your classes? How many would say yes, this idea of risk? Okay, not yet. That's interesting. All right. So this is how we think about risk. So what you're doing, you're often thinking about the hazard. Now you want to think about more holistically, which is how does that affect roads? How are the local population affected? Because all of these together combine to make a risk map, and that's what results in the final impact. So now, if we come back to this scenario of earthquake and tsunamis and landslides and flooding, think about before the earthquake. This might look like the photo in the lower left. After the earthquake, it might look like the photo in just to the right of it. And this is an example from central Italy. The roads will change, and that means emergency vehicles won't be able to follow the same pathways. Therefore, your whole concept of planning for risk will have changed. The risk is dynamic. So the hazard and the exposure and the vulnerability are changing. The infrastructure is changing, the exposure is changing. So you can't just do a hazard map based on what the infrastructure looks like right now, the roads. You need to plan for what would happen if you have successive earthquake, tsunami, how it will change the basic layout of the city. Otherwise, emergency vehicles might not be able to get in. Next. We can also think about humans. So if you have an earthquake, you can't just move people to a floodplain because there might be a flood later. And this has happened very often, where you'll have an earthquake, you move people, but that region is now prone to other disasters occurring. And so we can think about how humans might be influencing these on the short term, but also the medium term. So vegetation removal, that's going to accelerate drought in an area, or fire, or human-induced climate change is going to accelerate certain extreme events occurring. So what we did is we met with policymakers. We met with people such as the BMKG equivalents in the cities. We met with academics and we did workshops. We did them in Nairobi and Istanbul and Kathmandu. And we presented them some of these ideas. And what we asked them is, what hazard cascade scenarios do you think of that you would like to do? And if I had another hour with you, I would be having you come up with your own scenarios of what you thought was possible. And so I'm going to give a couple examples of these. So next. So these are a couple of examples that we had not thought of before we met with them. Heavy rainfall and windstorm can trigger flooding, but that can cause the electrical poles to fall down. And what happens then is you might have an urban fire. And so Nairobi brought this cascade of hazards, they said it's very frequent, to us as a possibility. So what we did is we mapped out many different cascades of hazards, their possibility. We consulted with people who were local to say, what might you be concerned with? We then asked them, how would you bring these ideas into policy? How would you bring them into practice? And they talked about challenges and opportunities involved with this. And so they talked about the opportunity that they get out of their silos. They don't just have the geophysics people talking to the geophysics people, but the geophysics people talking with the meteorologists and the climatologists. And that you start at least realizing that you can't just focus on your narrow speciality, that you need to think a bit more broadly, because the risk is interconnected. But some of the challenges are that often government agencies are very siloed. Often academic institutes are very siloed. What that means is we just focus our own little thing. When I was a PhD student, I was very focused on one thing. It wasn't till into my PhD that I started to broaden out into other hazards and start thinking a bit more holistically, which is, by the way, a good reason for you to do a master's degree or a PhD, because you start to think a bit more broadly. There's often centralized policy making. There's election cycles, so where's the money? And so all of these are challenges to thinking about multi-hazards. So I'm just going to do a summary. So I have 1 minute left of my first hour, and I'll just do a summary here. And so in these slides, I've focused on 5 papers, all of which you can download. They're not difficult reading. You can read them and understand them. But I also have other papers that we've worked on. And so we've looked at multi-hazards in water, We've looked at spatial temporal, and I'll just show a couple of these. So for instance, a multi-hazard framework for spatial temporal impact. A review of quantification methodologies. Everything I've discussed today so far has been qualitative, but we can also introduce quantification. And by the way, a lot of my research is very quantitative in nature. I use computer models and mathematical modeling, but I'm also interested in the social sciences and how we adapt social sciences to work with it. So that's why I bring in X and newspapers. I still can't get used to Twitter being called X, but that's life. And so we bring in all of these broad array of material. So what have I done here? Multi-hazards approaches offer a holistic way to assess natural hazards, particularly when considering urban risk. We've identified and reviewed the interaction between 21 natural hazards and identified 90 possible interrelationships. We've talked about anthropogenic processes, how they might influence. We've looked at systematic evidence approaches and how you use the literature and put single hazards and anthropogenic processes in the context of other hazards. We simplified what is actually very complex and broad-ranging material in a way that can be understandable to multiple stakeholder practitioners. And we thought about vulnerability, exposure, and dynamic. So I will go to the last slide and thank you and go to questions and comments.
All right, give applause. Thank you very much, Professor Malamud. So you have just delivered the talk very clearly. So I think hopefully all the students here can understand perfectly what you have just delivered. So, and the talk is really, really important. And I think your talk is, in this room is, how to say, very the suitable audience here, because they are meteorology, climatologists. Later, they will be the meteorologists, climatologists, and also geophysicists. So, yeah, what I have learned more or less before this talk, normally we do not really care about the interconnecting between the hazard. So normally we talk about a single hazard. But after this talk, hopefully all the students here or the lecturer, so now we have to think about how to mitigate the hazards, not only single hazards, but also multi-hazard, either simultaneously or also cascade multi-hazard. So I think there will be some questions here. Please, first I give opportunity to the audience in this room. Please raise your hand for the questions, and then later for the participants from online. So 2 questions first. Please mention your name and from which subjects you are coming from. You, please, please. Oh, lecturer here. Pak Adi? Yeah, please.
Check this. Okay. Check. Hello, I'm Adi from Meteorology Department. That was an interesting presentation. So I have a small question. Do you think we need to apply the weighted in making the dynamic risk assessment of multi-hazard? If since I think this disaster has different magnitude or impact of or severity. If do you think yes, how to do so.
Okay, so the question is on the connection of landslides with
Yes.
multi-hazards?
Yes.
Okay, and what was the follow-up of that question?
I think each disaster have different magnitude or severity. So I think we need to apply the weighted in making or to do assessment of dynamic risk assessment.
Yeah, and so the follow-up of that is on the landslide susceptibility and the different factors that influence the landslide susceptibility?
Yes.
Okay, so first of all, landslides are amongst the most triggered by other hazards of all hazards. So they can be triggered by many, many different types of hazards. I have quite a bit of research done in the landslide community, and I've studied a lot landslide susceptibility. So landslide susceptibility, for those who are not aware, is basically, do I have a higher probability or a lower probability of a landslide occurring in a given region? So I might take this room here, and I'd start saying, what's the soil type? What is the steepness? And then start thinking about the dynamic nature of the landslide. So yes, the answer would be yes, that in the landslide community, we are concerned quite a bit about the multi-hazard interrelationships that might trigger landslides, but also what the landslides might trigger, that they might cause floods, that they might cause a big landslide might cause an earthquake, a small earthquake. And so we are very concerned about the interrelationship. In terms of the variables that we use to inform the susceptibility of landslides, it's not just the environment around us. It's also things like how close is the landslide to a road, or how many buildings are nearby. And so we start thinking about the exposure. So in other words, the human assets, they contribute to that. So all of these play into a landslide assessment. And I would say multi-hazards is very integral to our thinking about landslides. Okay? Next question. And did that answer in part? Okay, I got a sort of a nod of a head, but not completely. Good. All right, next question.
Okay,
Could I
next
also,
questions.
and can I also encourage some of the women in the room to raise their hands? Because thus far it's only been men.
Okay, next questions? Yes, please, Riswa, student.
First of all, thanks for the opportunity to ask a question. I'm Ember Spariansyah, fourth year geophysics students. My question is, how do we encourage the policymaker to make a policy which will strengthen the resilience to natural hazard in Indonesia? Thank you.
Yeah. So the question is, how do we encourage policymakers to increase resilience to multi-hazards? This is always an interesting question. So the first thing is giving talks like this, because some of you will be later going on to BMKG. Actually, all of you will be. And some of you will then be interacting with policymakers. Another one is I meet with policymakers. I meet with their team. I talk with the scientists who are actually overseeing the natural hazard assessment. I meet with the policymakers, they take advice. It's meetings like this. It's putting money, it's asking the policymakers not to have the earthquake people in one building and the flood people in another building, but to actually talk with one another, to provide opportunities. So it's done at the level of the policymaker for money, and it's done at the level of the natural hazard manager for how to encourage communications. A lot of it comes down to communications. The final thing is places like the World Bank, the United Nations are very much aware of multi-hazards, and they are giving money to study these. So Nepal right now is thinking about developing a multi-hazard early warning system for all of Nepal. Okay? Does that answer your question?
Yes, it
Okay,
answered.
thank you.
Thank you for your answer, sir.
Thank you, Professor. Next questions. From online, maybe, can someone read the question from online? If probably there are some questions from online, then...
Okay, I can read one of it, and I'll just read it out. I'm just
Yeah.
not sure if I can do it with the microphone. So the
Yeah.
question is, I am Martha, and I am a fifth semester geophysics student. I would like to ask the opinion on how important is the crucial moment when some hazards occur, such as earthquakes that have a high possibility of triggering other hazards. And then there's a long statement. Because in my opinion, this very short time can save the lives of many people from the dangers that will come. In addition, the virtual reality is very useful to educate the public how dangerous natural hazards are. We know that under certain conditions, when a very large earthquake occurs, the local internet may be cut off or disconnected. Whereas nowadays, people rely heavily on the internet to find quick information. So we need an evacuation system, based on satellite radio, evacuation route, etc. So there's 9 or 10 things in this statement, which is very good. Let me just answer the first question. Is the crucial moment when some hazards occur, such as earthquakes, that have the high possibility of triggering other hazards? So let's take what we mean by early warning. So early warning means giving a local population or a government enough time to react to a disaster that might be occurring in seconds, minutes, hours, months. And so we have different time that we can use. For earthquakes, all of you have learned about P waves and S waves. So the time between the primary wave and the secondary wave. Sorry, let me just do this. How many of you know the difference between a primary wave and a secondary wave for earthquakes? That's the geophysics people. Okay, so this is...
They know about it.
They do know about it. Okay, good. So the time between the primary wave and the secondary wave might be 20 seconds. It might be 2 minutes. But that's enough time to have a warning system whereby the local population can be alerted. Or you can stop very fast-moving trains, or what is done in some countries, you turn off the gas valves so you don't have explosions and fire. So that time is very critical. We can't do earthquake prediction yet. That's not possible. But we can do a sort of early forecasting based on primary waves and secondary waves. So there are different volcanic eruptions, sometimes weeks before. We know there's an increased probability of a volcano actually erupting. And we can start using that. We might not know which direction the volcano will erupt, but we know that it's more and more possible that it might erupt. And this you are thinking about quite a bit here. Weather forecasting. We can do different types of weather forecasting on days, sometimes hours, sometimes months ahead of time. We know about El Nino, La Nina. That's years ahead of time. We know that a given year might have more extreme weather. So we use these and we alert the local population. Now the other part of that is using local technology like virtual reality. You can create virtual reality simulations to give to people so that they can do an evacuation route. So evacuation is only as useful as the people that use it. An evacuation route is not useful unless people know where to evacuate to and how to evacuate. Let's move to another question. And by the way, questions can be on anything. They can be research, they can be Durham, they could be, I don't know, I had a camel when I lived in Africa. Can
Oh.
talk about the camel.
Or maybe opportunity, the question about the opportunity to study in Durham University. The opportunity to study in Durham University.
Okay.
Probably they also have the questions.
Okay, so Durham University is one of the 17 UK universities that is in the scheme where you can study for a master's degree or a PhD after you graduate from here. And so there are 17 universities. We currently have in the UK 40 students studying for masters and PhDs that are fully funded by the Indonesian government. So there's a lot of opportunities. And one of the things for you to think about is, do you want to go to a big city? Are you interested in studying in Durham? So if anyone has questions on Durham, I'm also happy to answer those. And what it's like to live there. It's cold.
Okay. Okay, back to the topics today. Any other questions from the room? Yeah, Farhan. Okay, please.
Tes. Okay, thank you for the time. Let me introduce myself first. My name is Farhan Wazofiro. I am the third year of geophysics student. I would like to talk about the matrix. You were talking that we know, we can agree that earthquake is a key to the other hazard that will be occur. But we know in geophysics, we can't forecast or predict where and when the earthquake happen. Maybe we can predict where the earthquake happen, but we can predict the wave. We know that the earthquake hazard is not the landslide deformation or land deformation, but the wave that can occur the other hazard. That's our bigger problem in the geophysics. How can we treat that what we call it, that weakness in the geophysics, so we can more
Anticipate.
yeah, so we can anticipate earthquake that can occur another hazard and another event. Thank you.
Okay, good, thank you. So the comment in question is that earthquakes, we cannot predict where and when and how big they will be. That's absolutely true. I agree with that. But we can do probabilistic hazard forecasting. And you're aware of this. And this means we can say, in a given region, I have a 1 in 10 possibility of an earthquake of this size or bigger occurring. And that gives us the location, region, the probability, so it's a probability, and the size of it. And so we know that we can do probabilistic hazard forecasting for earthquakes. From this, we can say the likelihood of an earthquake occurring in a given region, and we overlay that on landslide susceptibility maps. So let's say I know that this area, there's a higher chance of landslides, and this area, there's a lower chance of landslides, because one is very steep and one is very shallow. That means if an earthquake occurs, that the steeper area is more likely to have the landslides. I'm not going to predict The landslide's going to occur here, but I'm going to now be able to say where it is more likely and where it is less likely. So when we do landslide assessments, we bring earthquakes into our thinking. We do dynamic risk assessment. So we link the earthquakes to the landslides when we're thinking. We also do the same thing for floods. We say, here's the probability of a given size earthquake occurring. Therefore, a flood might occur here or here. Have you learned about peak ground acceleration yet? Okay, so peak ground acceleration is how much the ground will move in an earthquake. And it's measured based on acceleration of the ground. So it's in measures of gravity. And what you can do is you have maps of potential peak ground acceleration for a whole region based on a certain size earthquakes. From that, it gives you a good idea of landslides. I can't tell you it will be tomorrow or it will be 5 years from now, but I can tell you it's more likely or less likely, the landslide. And this, by the way, goes to the heart of what you would be doing with a master's degree. You would be thinking about this anticipation. This would be part of a project that you're working with. So it's very interesting research that you're talking about.
Great, thank you. Good, next questions? Yes, please.
Okay, thank you. Good morning, Professor. In this occasion, I would like to ask you about landslide. It could be interesting if you talk about landslide, because I saw that you talked that in past 6 years your research is about landslide. Well, as your presentations, landslide could be caused by many hazards, of course, and maybe in several places it will be different with another place. If you talk in Indonesia, what kind of hazard that frequently cause the landslide, and can us make early warning about the landslide? Because as you know, the landslide is maybe one of the complicated hazard, because it may be caused by earthquake, flood, and another. Okay, thank you.
Okay, thank you. So the question is on the triggering of landslides. What causes landslides in Indonesia? And I think that was what causes them. What else was the question? Early warning.
Early
of
warning,
landslides,
yes.
yeah. So landslides in Indonesia can be caused by tsunamis can actually cause landslides, by the way. But the most common cause in Indonesia are going to be volcanic eruptions. And so lahars are coming from landslides. Earthquakes, you have landslides. You also have landslides, so earthquakes, extreme rain is causing landslides. So you often have a lot of events where you have landslides resulting. Each one of them is a different type of early warning system. So let's take the early rain, the extreme rain. And so if you have a sudden downburst of rain or lots and lots of rain over a given period, what would be the forecasting tool you would use for landslides would be weather forecasting. And so this is what we did in India over the past few years, is we developed an early warning system for landslides based on meteorology. And so it's based on pressure systems within the atmosphere, how they group together, and what might be more or less likely to cause landslides. Heavy rain, which would cause landslides. And that generally will give you a forecast days to weeks in advance. It won't be, there's going to be a landslide here, but rather over this 1 or 2 square kilometers, we will expect heavy rain. The heavy rain might result in landslides. Volcanic eruptions, you already know how and what we can do with volcanoes. We have all sorts of tools to do early forecasting of potential volcano eruptions. And one of the things we're very concerned about with volcanoes is if it erupts, what would be the cascading hazards that might result? So one of the slides I didn't show you, it was the slide after my end slide, is I went to North Korea a few years ago, DPRK.
Slide yang setelah slide terakhir.
It's fine. But I went to North Korea and I gave a talk about multi-hazards. And the reason is they have a volcano in North Korea that they're very concerned about. It borders China and North Korea. And I wanted them to be thinking about the multi-hazard cascades that might result from that. And so, again, you get landslides there, but it's only as good as the volcanic eruption. Go a couple slides before this, please. So before, previous, so back, go back.
A bit delay.
Go back a little bit more. And one more. So this is in North Korea, all right? I gave a similar talk, but in 15 minutes. And we had North Korean scientists and Chinese scientists that talked about multi-hazards. But the concern there was, if you have a volcanic eruption, what will be the cascading hazards that result? And that's only as good as the potential forecasting that you might have from it. So volcanic eruptions, earthquakes, we're just not very good at forecasting them. So we have very little lead time. I'm just going to mention a slide here. If you would go forward, since we're on landslides. So advance, and advance one more. Yeah, keep going. So there are other things. So like newspapers can be used to better understand landslides. And this is work that we did using newspaper reports. And I'm in discussions with an Indonesian colleague how we might mine the newspapers. Next. This is looking at social media and how we use social media to look at natural hazards, both pre, during, and post. Next. This is using serious games to think about landslides. And so we can use serious games, playing cards, so that we can educate the local population. Next. Next. And that's the serious game. And the next, expert elicitation. And finally, one more is looking at roads and how landslides influence roads or roads influence landslides. That's enough, thanks. You can turn that off now. Okay, any other questions? And by the way, I've noticed,
Sorry? Okay. Yes. Yeah, sure. Any women students would like to ask questions? Please.
So at the workshop yesterday, there was a nice mixture of both
The
women
online-
and men speaking.
Excuse me. The online questions actually
Oh,
from
that was
woman.
Martha. Okay, you're right. Martha was. All right.
Probably there are some other questions. Please.
Okay. Any other questions?
Okay. Anggun, please. Yes.
Thank you so much, Mr. for the opportunity here. I am Anggun. I'm from geophysics, and I want to ask about how could you massify your research to people in impacted environment? I mean, like, if you're saying it in lecture like this, not all people know about what you are saying like that, and how are you massify your research so that people in surround environment that impacted on in the hazard will notify that they are maybe in danger like that? Because example, in a short time, especially in Indonesia, we have an issue about megatrust earthquake, and we have done saying it to people, but they're not. They're just a little bit people who have aware about what we are saying like that.
Okay.
Okay.
Thank you. That's a very good question, which is basically, how do you communicate something that is slightly technical to lay people, to people in a local community? An example was the serious game that I just showed you, and I should have waited for the serious game. So that's a card game, and it has very simple text on it. We've developed it for northern India, so it's written in Bengali. We've written it, and it's basically, we've been trialing it with local groups as to how to do landslide mitigation and what might cause a landslide. And so you have pictures coupled with words. People play the game, they get points if they mitigate, and they lose points if a landslide occurs and they make the area more risky. And so you can bring in earthquakes and landslides there, the idea of multi-hazards. In the Philippines, in 2 weeks, I'm going to be doing a workshop with high school teachers. So I'll spend a day with high school teachers, and I quite like doing what are called hands-on demonstrations. So for earthquakes, I use a slinky, a spring, to demonstrate primary waves and secondary waves. For landslides, I take a bottle, I put sand in it, I rotate the bottle to show what happens with the sliding of the grains with and without water. So there are ways of talking with the community, but not treating them as not intelligent. They're very intelligent, they have local knowledge, they have things they can share with me, but you're communicating in a very different way, sometimes with pictures, sometimes with objects, sometimes with sound, and with visual. So it's a different way of communicating, and this is something I've been working with different PhD students on, which is how do we reach and talk with different groups? All right?
Thank you.
Yeah.
For your information, these few weeks or few months, last 2 months maybe, we we informed the people that there is potential of megatrust earthquake. Some people react or respond positively. For this is the warning, so we have to care about it. But some others they respond negatively. So in this case, you're right. We have to communicate correctly with the people. Good. Thank you. And then it's almost 11. We still have opportunity for the 2 questions. Please. Yes. One more? Okay, over there. Two more questions, and then we will stop. Yes, please.
Check. Okay, first of all, I want to say thank you for the opportunity so I can asking my question to Professor Bruce Malamud. First of all, let me introduce myself. My name is Dwi Purwanda. I'm the third year cadet from meteorology. So my question is, there was a typhoon, recently, there was a typhoon that happened or occurred in Vietnam, which called Typhoon Yagi, which has killed around 60 people. I got this news from BBC News, by the way. So my question is, what is the indicator that the mitigation or resilience of a country is good or successful? Because as I know, in every disaster, there must be a damage or is always causing destruction. So I think it's almost impossible that in a disaster, it not taking any damage at all. So what is the indicator that the mitigation or the resilience of a country is good or successful? I hope you understand my question. Thank you very much.
So thank you. So the question is on, are there measures of the resilience of a country? And you brought up the very devastating example recently in Vietnam, where there were over 60 fatalities. So there are indicators of risk and resilience. So let's start off with risk indices. And by the way, Indonesia is near the top of this. What is the risk of a country? So it's not just the hazards that the country faces. So you face multiple hazards in Indonesia. That's absolutely true. But it's also the infrastructure, the emergency preparedness, the vulnerability of the local population that all play into the risk index. Now, the resilience is the ability of a community to withstand a shock. And this, there are multiple indices out there for resilience that we are working on and trying to better determine what creates resilience. So I'll give you an example. Resilience might be better buildings. Perfect, we all know that. If you build a building that's earthquake resistant, you're less likely for it to fall down. That's a type of resilience. But there's another type of resilience which we don't often think about. It's the interconnectedness of people. And so one of our professors in practice at the Institute of Hazard Risk and Resilience, he is an expert just thinking about how connected people are. Because it's been shown the better people are connected with one another, the more resilient they are going to be when a disaster occurs. So why is this? This is because when a disaster occurs, they have people to go to. They have a communications network. They have a family. They have a community. They might have good linkages with the government. And so they have a good rapport as to what to do when the disaster occurs, this interconnectedness. Another measure of resilience is how corrupt is a government. The more corrupt a government, the generally less resilient a society. Why is this? This is because if you're making building codes, well, what happens then if someone pays off someone with a bribe and the building is not built to that standard? And so there are papers that have been related to how a government deals with corruption and how resilient the society is. Then you can go to emergency services. So all of these play into different indices of resilience. And it gets into why the business school was very interested in my talk. They were interested in the resilience parts of it, how they might increase resilience from the supply chain, from the interconnectedness, from an economic point of view. A psychologist might be interested from it, from how do we make sure that people are talking with one another, that communities are aware of what is happening. So there's many aspects of resilience which I hope you, all of you, consider as you're moving forward, no matter what it is that you are going to be studying, is how do we create a more resilient society? Because that's ultimately what the BMKG is here for. You are trying to create better resilience to a whole host of natural phenomena.
Very important explanation. Thank you. I think it's a very complete answer. So, last questions, please. We are approaching 11 o'clock. So it's okay.
That's great.
Thank you for the opportunity, Professor. My name is Ilham Mutahari. I'm third year instrumentation student. You've mentioned it before that this multi-hazard relationship can predict or protect risk in the future. So that means early warning system, the design of mitigation and adaptation strategies can be adapted to account for this interaction. But I'm still curious that there's lots of challenge of modeling dynamic risk scenarios, especially in our region. My question is, how can we monitoring this system to reflect the evolving natural risk in multi-hazard environment? Thank you.
Okay, thank you very much. So if I understand your question, it's how can we model multi-hazard risk? Is that correct?
My question is, how can we monitoring this
Monitor.
system?
Okay, monitor them. I think monitoring starts with the single hazard. And so that means we need to monitor the earthquakes, the volcanic eruptions, the floods. From that, we can start thinking about what hazards might result from it. So I'll give you an example. We have a very good monitoring system now, which is the pair of earthquakes and tsunamis. We have a network that we have developed. There's an earthquake, we then have tsunami, basically the pressure monitors at the bottom of the ocean, which can monitor how big the wave is that is passing over all in the ocean, from the bottom of the ocean to the top. So that's an example of an effective multi-hazard early warning system that couples the earthquake with the tsunami. Another example would be an earthquake with a volcanic eruption with a lahar. And so we know that in a given volcano, that there is a good possibility that if there's a lahar, it will be on one side or another side of the lahar, because they generally go down where the topography is the lowest on the volcano. So then we know that if there is a heavy rain and there's already ash, that we know where to start looking. We can put video cameras there. So we look pair by pair at each hazard pair, and we say, here's how we monitor the first one, here's how it might affect the second one. And we just use the instrumentation, and we think about how to instrument that. Okay?
Good. Thank you very much, Professor Malamud. Please give applause to Professor Malamud. So I'm not going to conclude the talk. No, we are coming to the end of the talk. Hopefully later these materials of the talk I'm going to share. So the professor will share us this material, and hopefully after listening to the talk, we understand much more about hazard. And this will be the motivation for the students, for all of us here, to study much more about hazard. And finally, hopefully in the future we can mitigate the disaster much better. Thank you. Thank you, everyone. I give it back to MC.
Thank you for the speaker and also Dr. Musli for leading this amazing session today. Excellencies, participants, ladies and gentlemen, now let's capture the spirit of collaboration and togetherness with a group photo. I invite all of our speaker and participants to join us for a memorable group photo. The photographer will take the photo from the stage, so everyone in this room can join to the group photo. Please let me count for the photo. 1, 2, 3. Once again. 1, 2, 3. One, two, three. Once again. 1, 2, 3. One, two, three, and maybe the freestyle. One, two, three. Participants, ladies and gentlemen, and that's a wrap for this agenda. We are grateful for your time and attention given in this agenda. On behalf of our committee, may I apologize for any mistake that has been made. Once again, thank you and good afternoon. Wassalamualaikum warahmatullahi wabarakatuh. The attendants are allowed to leave the meeting.
Recording stopped.